Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of line in R3. So as per the problem, show that the following two sets of symmetric equations represent the same straight line. Two equations represent the same line if they are parallel to each other and a point that lies on one of the line also lies on the other line. So let's start by proving that these two equations represent parallel lines. So for that, we'll have to analyze the direction vectors from these two equations. These equations are in symmetric form. The components of the direction vector of the line are the denominators in the fractions. So for the first line, the components of direction vector are 8, 2, -2. The components of the direction vector of the second line are -4, -1, 1. Now we have to compare these two direction vectors to check if they are equal to each other or scalar multiples of each other. If that's the case, that means these two equations represent parallel lines. If we compare x, y and z components of these two direction vectors, we can see their ratio is the same. 8 divided by -4, the x component is equal to -2. 2 divided by -1, the y component is equal to -2, and -2 divided by 1, the z component is equal to -2. So this means that direction vectors m1 and m2 are scalar multiples of each other. If I multiply vector m2 by -2, I get vector m1. So this means that the lines represented by these two equations are parallel. Now we have to prove that a point that lies on one of these lines also lies on the other line. So we can use a point that lies on the line on the left side. For that, we have to use the number terms in the numerator of the fractions. So with x, the number is 7. With y, the number is 1. With z, the number is 5. The general equation of a line in symmetric form is in this general equation, x naught, y naught, and z naught represent coordinates of a point that lies on the line. So if we compare the general equation with the given equation, x naught is equal to -7. So we flip the sign of the number term in the equation. Y naught is equal to -1 and z naught is equal to 5. So a point that lies on that line is -7, -1, 5. Now we have to check whether this point lies on the line represented by the other equation. So for that we should sub in x as -7, y as -1 and z as 5 and see if we get the same result from each fraction. We get the same result from each fraction. So that means that the point -7, -1, 5 also lies on the other line. So that proves that the symmetric equations represent the same straight line because they are parallel to each other and they share a common point. Point -7, -1, 5 lies on both lines. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.